This is lab9 power in AC networks. For AC network, the definition of complex power S equals V times I conjugate. Here V and I are both phasors, so it equals Vrms times Rms, and the angle equals the difference between the voltage and the current. And be careful that they have different units. The units of S is volts ampere. And also the S can be decomposed into the real part and the imaginary part. The real part is P, the imaginary power, and the imaginary part is Q, that is the reactive power. And also we can define power factor as P over S, and it equals cosine theta V minus theta I. In real applications, we want our power factor to be close to 1. Figure 1 shows the power triangle. If we know S and theta, we can use the sine and cosine function to calculate Q and P. Sometimes the P is a fixed value. In order to minimize S, we need to minimize theta. That is, it is our goal to minimize the angle between the voltage and the current. We want it to be closer to 0 so that the power factor can be close to 1. Figure 2 shows the circuit for pre-lab and experiment. In the pre-lab, you will be asked to do a lot of calculations on this circuit. Let's take a look at what we need to do in the experiment. First, we need to use the oscilloscope to measure the phase angle between the load voltage and the current. Because the oscilloscope cannot measure the current directly, so what we do is that we use the oscilloscope to measure the voltage. And because this is a resistor, so the current can be obtained by using the voltage over the 100 ohm resistor, so we can obtain the current. In this step, you need to do a lot of measurements on voltages, because you measure this voltage and also you obtain the current by using the voltage divided by the resistor. You can obtain the current. So once you know the voltage, current, and the phase angle is obtained in the previous step, so you can obtain S and you know the angle. You can use it to calculate the real power and reactive power. Third step, you need to calculate the capacitance needed to be placed in parallel with the load to raise the power factor to unity. So we have the power triangle P and Q. What we can do is to reduce the Q to 0. So we put a capacitor in parallel with the load so that we can reduce the Q to 0. And the equation we use equals Q equals omega C V squared, so we can calculate C. For the pre-lab questions, you can use the series and parallel relationship to simplify the load and calculate the impedance. and the solutions will be discussed in another video. That's the end of this lab. Thank you.